Hi everyone, this is Benham from Banks and Markets. I hope you all are keeping well. This video is about normal distribution tables. Basically, I want to explain how these values inside the tables can be derived. And by doing so, I hope that it will be clear to you which tables are giving what values and why they are different from each other. So for example, this is standard normal cumulative probability table, and if you go into this and if you, let's say for example, search the value when Z equals 1, then it is telling 0.8413 or 84.13%. Whereas if you go into another table which is called right tail probabilities, then for Z equals 1 it is showing you 15.87%. Now again, if you see something like this, let me find the table here, which should be this one, not this one, the first one perhaps. Yeah, this one. Then this explains those values that we saw in different tables. This provides in a more interactive way. So up to Z, when Z equals to 1, similar to what we saw earlier on here, 1 equals 0.1587. This is what we are able to see. But if we do Z onwards, then we see 84.13%, and this is what we saw here before. And again, if we say from 0 to 1 or 0 to Z, then we see 34.13%, which can also be found in tables such as here, 1 equals 34.13%. So I just wanted to show you how these values that are inside these tables can be generated by yourself. And while explaining those, you should also be more knowledgeable about different types of tables, and therefore on the application as well. Now remember, I'm talking about these mainly because I teach on topics as value at risk, and in these topics, including my other topics such as those related to investments in financial securities, these assumptions of normality distribution are inherent. So it's important that you've got those understanding. It's not only in finance, risk, or investment. The uses of normality distribution, if you go and see, it says you can use it to determine the proportion of the values that fall within a specified number of standard deviation from the mean. Like this is the technical definition, but in terms of uses, it is used business, okay, you can see operation management, employee performance, so many applications, social science, everywhere. Hence it's even more important that we've got better understanding of the values reported inside these tables. So what I would like to do on this topic, therefore, is to help you find those values yourself and also see that nice bell-shaped diagram that you can create in no time, actually. You may know that normal distribution, these properties are there for various variables such as the height of people. Okay, height of people or weight of people or temperature of people, or you can also think of, the lifespan of a light bulb. You may have learned this in statistics that these will follow the properties of normality distribution. And in investment, we say stock price returns, they follow normality distribution assumption. So with that in mind, I just want to make it a little bit interesting by presenting the height of various people. So what I have done is I just went to like some websites to see some popular names, so most popular baby names of 2021, and I have those 100 names here. Okay, start with the girls. So the most popular names of the girl here, as you can see, is Olivia, and I think somewhere here is the boys starts from 51, so Liam is the most popular in terms of boys. So that's interesting, but this is only 100 people. So what I want to do is increase this to, let's say, 1000. So I just want 1000 names. What I'm going to do is I'm going to type all 1000 names here, and I'm just going to assume that there are so many people with same name. So I'm going to make use of these 100 names to make 1000 names. So that's it. Basically, you do not need to worry about what I'm doing here. So basically, I'm just creating the name list of 1000 people. Okay. And that's not difficult because when I'm going to use rand between function, this will enable me, and I am saying take all the names from row 1 to row 100, and then just produce the name randomly. Okay, therefore I use the function rand between. So therefore I got this. Now I'm going to copy it all the way to that 1000 row. So now I've got 1000 names, which then basically means without my influence, I now have 1000 names. This column A is not relevant to me now, hence the reason why I have minimized it. What is important for me is column B, where I've got 1000 people. Now what I said to you is I want to make use of the height of people in order to find the values in those different types of table. I live in the UK, and I know that the average height of the people in the UK would be, for male, I know I had read somewhere it's around 179 centimeter. But this is just an example, and just to make it easy, I will just say that the height of the people is 180 centimeter. But some people will be tall, very tall, and some people can be very, very short. So in terms of deviation from this average height of 180 centimeter, I would just say they would deviate by 10 centimeter. Okay, so this is what we call like average height, and this is the deviation, and sometime we like to be more technical, therefore I'm going to make use of the term standard deviation. So this is what I have done. Now my job now is to find out how tall are these people, how tall is Sebastian, how tall is Emma, how tall is Nova, and so on. Now, if I need to measure, then I need to call each person, make use of the measurement tape, and record the height. But this is just an example, and I'm not going to waste all that time. And I don't even have those 1000 people with me. So what I'm going to do next is, therefore, I'm going to randomly assign the height based on these properties. And one way to do that is, again, to make use of the standard normal distribution assumption. And in Excel, there's a function called equal norm_inv, and that way it allows us to record them. So for that, I need to define the probability, and I will say randomly assign the probability. So when I use the word rand, open bracket, close bracket, this is going to give me a number between 0 to 1. So that's fine. And then I need the mean, which is this 180, and I also need the standard deviation, which is this 10. Okay, so that's what I have done, and it's not difficult. But what I don't like is this 0.123. So I'm going to tell computer to round it to 0 so that I get the whole number in the screen. And apart from that, what I also need to do is I need to lock these cells, and once I will have locked them, I can now double click. So I've got the height of all 1000 people, as you can see here in this column. So next, what I want to do is I want to make something similar to these tables. So in these tables, what I have is like, Jed from 0 to, as you can see, 3.4. And you will also find in some other places, like there is starting from Jed. Again, where does it stop? It stops 3.4, but it starts from minus 3.4 and so on. So I will also apply the same approach. So minus 3.4 to 3.4 is here. I will just say I want to have like minus 4 to 4. With that in mind, first thing what I will do is I'll find out what is the tallest height. So equal max is what I can do to find the tallest, and that's 213. So let me write it here. So I'm just going to say max and then minimum is then equal min of, again, the same range, 1000 people, and that gives minimum, that's 153 there. But what I will do here is I will say the shortest person among these 1000 would be 140, and you see this is giving 148, and this is 211, so I want to go all the way to 220. So that then basically means I can do something like this and go all the way down to 220. I don't need them, just until 220, and that's what I wanted. And this is a good, classification range, yeah, from 140 to 220. Now, once I have this, what I can now do is I can assume these are my x's, and therefore now I can find my z. Now, when it comes to z, you may know the formula for z, which is x minus mu over sigma, or I can just find here z formula normal distribution, and you can see it is x minus mu over standard deviation. That's the one. So this is what I'm applying here, the same approach. So x is this minus mu, which is the average. I'm going to log this and divide by standard deviation. Again, I need to log this because I need to drag it down, and I need to put it inside parentheses, otherwise it will be wrong. So now I've got minus 4. And if I bring it down all the way to 220, I can see that I now also have those range of z values. Here it is from minus 3.4 here all the way to 3.4, but in my case I've got even higher values like minus 4 all the way to 4, so that's fine. Now what I want to do is I want to find out how many people do I have who have the height such as 140, 145, 150, and so on. So to do that, what I can do, just for convenience, I'm putting it on this side, and now I can make use of the frequency function. So I've written down 1 just to stop there. Now I'm going to say equal frequency, open bracket, and this is my data array, and then this is my bin array, basically the classification thing. And once I close bracket, I need to press Control Shift and Enter, not just Enter, Control Shift and Enter. So this is telling me the story that majority people are having that mean height score or surrounding it. As you can see, these are the high frequencies. So this is already giving me some idea that this height follows a normality distribution. But in total, I should have 1000 people. So if I add them all together, I get 1000. So this means I have captured everyone in my data set. So that's fine. Now I'm more keen about the values that we see in this table. So I will just go and see what is it for 1. For 1, it is 0.8413 or 84.13%. So I want to find something similar. So here, therefore, what I can do is I can take the proportion of this to the total, which is 1000, and I lock it so that now I can drag it down, and therefore when I add these all together, what I should receive is 100% or 1. So that's fine. Now I will find the values. So for example, when z equals 1, what is it, the value given by that cumulative normal distribution table? And we saw that it was 84.13%. So do we get something similar? So if you just add these all, because it's cumulative, starts all the way from the beginning, then you get something very close, okay? You will see that I'll be able to find that 84 itself. Just give me a second. Now, next, we also have other types of table, such as right tail distribution table, where 1 is giving 15.87%, which is this. So for that, what you can do is 1 equal 1 take away this, okay, and so it's giving you somewhere closer to 15.87. Now I also set to you another table which is here, and this is, as you can see, from 0 to Z. Okay, so that then basically means from 0 to Z for 1 is 34.13. So can we get that? So for that you need to think from 0, so that's halfway through, so that's 0.5, take away this value here, so we get this. So this is like cumulative, this is right-tailed, and this is 0 to Z, and therefore you get these values. Now if and then you can do that by pressing F9, or even if you type something in your computer, you get this. So can you see now I'm stopping? That's 84%, that's 15%, that's 34%. That's what we were talking exactly before. So up to Z 15, Z onwards 84, 0 to Z 34. That's what we are able to see here, which basically then means you are able to create these value yourself just by assigning these standard normal distribution properties. So hopefully this was helpful, and by engaging in this exercise, I'm assuming you are also able to understand different tables better. Thank you very much for your time, and thank you very much for listening.